Case number 28. Let's look at the identity of 1 over tangent x plus cotangent x be equal to the expression sine x times cosine x. We are to verify this given identity, and we are going to manipulate the left hand side of the equation and see if we could come up with an expression similar to our right hand side. The reason why we are going to pick the left hand side is because tangent x and cotangent x can be expressed as a combination of cosine and sine x, which is actually similar, or the terms or identities that can be found on the right hand side. Our numerator is just 1, so we'll stick it as 1. So we'll have it like this: 1 over the entire expression in our denominator, which is a combination of tangent x and cotangent x. Now we could express tangent x, okay? So let me have it a little bit higher here. So 1, this is equal to 1 over, okay, tangent x can be expressed as sine x, okay, sine x over cosine x. That's just tangent, plus our cotangent x is cosine x over sine x. Okay, now that we are done with that, we are just simply need to combine our denominator here. Okay, so I mean the expressions that can be found in our denominator. This is still 1, okay, over the LCD. When we're going to combine these two, because they are both rational expressions that they behave like fractions, so the LCD is their product. So the LCD is their product. You have here cosine x times sine x. Okay, that's their LCD. Now let's try to come up with our expressions here. Cosine x sine x divided by cosine x. So we're going to cancel this. We have sine x left, to be multiplied with another sine x on our numerator. Again, this entire expression to be divided with this is sine x times sine x. You will have here sine squared of x, or sine x times sine x, you have sine squared of x. Okay, if you're not convinced with that, of course, with looking at this, you can remove one sine and remove that. Sine over cosine is similar to our first expression, so that's your way of checking. Another, cosine x sine x divided by sine x, so we're going to remove that. We have cosine x times another cosine x. You will have here cosine squared of x. Again, if you would like to pair these two, we have to remove one cosine and cosine here. You have cosine over sine, similar to our second term. So we're not necessarily changing the value of the expression. We are just changing the picture or the image of the expression. Don't forget the plus here. So you will have that. Okay. Now from this, take note this is an expression which is considered a Pythagorean identity. The sum of sine squared and cosine squared of the same angle x is just equal to 1. But let's not apply it in the meantime. Let's apply it later, as I'm going to add here another operation. We have here 1 over a fraction. Just like when you have 1 divided by 1/2, or 1 divided by 2/3, or -4 divided by 5/7. You are just going to use here the idea of the keep change flip method. Take note that 1 here can be expressed as 1 over 1. So you are dividing now two rational expressions. And with that, you're just going to use the keep change flip method here, meaning you keep the numerator or the entire dividend. Again, I'm just writing 1 over 1, okay? So we could apply it correctly later. And then, we are going to have multiplication instead of division. This one here, not this division, but this division here, the original one, before we transform tangent x and cotangent in terms of rational expressions. So keep, change, and we flip this. Flip meaning we're going to reciprocate that. Cosine x, we have here sine x over this one here. You have sine squared of x plus cosine squared of x. And with this, we simply need to multiply numerator to numerator, denominator to denominator. Of course, 1 times this is that alone. Okay, cosine x, sine x, right? But our denominator is 1 times this. And again, this is a Pythagorean identity equal to 1. So 1 times 1, we have 1 here as well. The final form for this step is just to arrange this because they are under multiplication. This is commutative. Addition is, multiplication is commutative. So we can simply rearrange that so that we could arrive to our goal. So we have here sine. That's sine. Sorry. X times cosine x. This is the same as our right-hand side of our given equation, and hence we have established that 1 over tangent x plus cotangent x is equal to sine x and times cosine x, the identity. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.